Actually, KL-divergence is a non-symmetric difference between two probability distributions. In this tutorial, I will cover the discrete cases of KL-divergence. I basically decided to capture three important issues. First is how to compute KL-divergence. KL-divergence with or without smoothing. Second is how to use KL-divergence, which is actually a non-symmetric type of measure, as a metric to calculate the similarity or dissimilarity or distance between two documents. Third is how to utilize KL-divergence to compute the mutual information. But now let us start with a very simple explanation of KL-divergence. Suppose we have a probability distribution A with n events like A1, A2 up to AN, and PA represents the probability of occurrences of events A1. Here we should also satisfy another property like probability of sum of occurrences of all events like up to is equal to 1, or in short we can say that is equal to 1. Now suppose B is another probability distribution with same n number of events and also satisfies the same feature like then we can calculate the KL-divergence between two probability distribution or the difference between two probability distribution by using KL-divergence formula like this. This indicates that probability of occurrences of event AI from probability distribution A log E probability of occurrences of event AI from probability distribution A probability of occurrences of event BI from probability distribution B, and simply we can calculate the KL-divergence. But here we should consider a very important point. Both probability distributions A and B should be defined over the same type of outcomes. For example, if we define the probability distribution A by collecting the events through rolling some dice, then B should also come through the same kind of events, or we can collect both through some other events like tossing coin, or in case of text mining it may be like identifying the occurrences of different words or sequences from a given fixed vocabulary. Now we will explain the KL divergence through a simple example and also explain the cases of smoothing. Suppose we have two probability distributions obtained from same type of outcomes. For example, is first event is like 1 by 2, second event PB is equal to 1 by 4, third event PC is equal to 1 by 4. Second probability distribution B is given like first event is equal to 5 by 8, second event is like 1 by 8, third event is like 1 by 4. So we have three events in two probability distributions. Now you can see that both probability distributions satisfy this equation, means sum of probability are equal to 1. In this case also it is equal to 1. Now here it is very easy to compute the KL divergence between two probability distribution A and B by just putting the formula. But now consider two different cases. In case 1, suppose our first event in probability distribution A is equal to 0. Similarly, first event here in probability distribution B is also equal to 0. This means that both events says that this event is not possible. In this case, computation doesn't create any problem. For example, if we apply this formula, to compute the probability here, then it will be equal to like 0 into and this can be expanded like 0 into and this is equal to 0. So it will not harm or it will not create any problem in computation, in the entire computation. Same may be possible with the second event, third event or any of the nth event if the probability distribution contains n events. So same cases may be possible. But now suppose we have case 2 such that probability of occurrences of event A is equal to 0 related to probability distribution A. Similarly, probability of occurrences of event A is not equal to 0 related to probability distribution B. This means that the first event of probability distribution A says that this event is not possible, and similar at the same time the first event of probability distribution B says that this event is possible with some probability greater than 0. The reverse may also possible, like here it may not be equal to 0 and in this case it may be equal to 0, and the same case may occur with second, third or any of the nth element, any of the nth event if the probability distribution contains n events. So in this case it will create some computation problem. Now suppose start with this part, then what will happen? Then we can use this formula as it is. Then for the first part it will be equal to some value greater than 0, like b greater than 0. So in this case it may be equal to 0 into minus some value b greater than 0. This part will be equal to minus infinity. So entire divergence will be equal to something like infinity. So computation may not be possible in such cases. How to solve the computation problems in such cases? So in such cases we use the concept of smoothing. Here we use absolute discounting based smoothing method. To solve this problem. So how to use this method? Now suppose we have two events. Suppose we have two probability distribution A with 4 events. Like first event probability is 1 by 2. Second event's probability is like 1 by 4. Third event's probability is like 1 by 4, and fourth event's probability is 0. Similarly, we have another probability distribution with 4 events, such that the first probability distribution the first probability of the first event is like this, probability of the second event is, probability of the third event is 0, and the probability of the fourth event is. Now we have to compute the KL divergence between A and B. So how to compute this? So in this case, according to the concept of absolute discounting, now the steps are: the first step is take a very small constant, say it like EPS is equal to 0.0001. Now take the non-zero elements from the probability distribution A, which is equal to A, B and C. Now take a count of events having non-zero probability score, which is equal to 3. Similarly, we repeat the same case. Count of events having non-zero probability score is A. Similarly, the set of non-zero probability score in the probability distribution B is A, B and D. So the count is the next part is count all the distinct event, which is equal to SA union SB, and we represent it like S, which is equal to ABC union A, B and D, which is equal to A, B, C and D. So count is Now the next computation is very easy. We apply a simple algorithm. We modify any event I like ai minus x if the event is non-zero and present in the probability distribution A, or we can say that if x is in A with probability of greater than 0, where x is equal to EPS divided by this count CA. The next part is A dash I is equal to EPS if x is not in probability distribution A or equal to 0. So in this case our probability distribution A can be represented as minus x Similarly, we can represent B as here the C is equal to 0, so we can represent it as minus y here y is equal to EPS divided by CB, which is equal to EPS by 3. Or we can, in more generalized way, we can compute x as EPS into mod of S minus SA divided by mod of or cardinality of SA. So S is our set obtained from the union of SA and SB. SA represents the events, non-zero events or available events from the probability distribution A. SB represents the non-zero probability distribution, SB represents the set containing which exist in probability distribution B or having non-zero probability. Similarly, y can be computed as EPS into S minus SB divided by mod SB. Here SB is the already discussed that set of events which exist in the probability distribution B, or we can also say that set of events for which probabilistic score is greater than 0. So this is the way we can change the value in each cases, and now we can compute the KL divergence score between A and B. So we have successfully discussed about computing the KL divergence and using the smoothing in the simple cases.